Hello, how are you? So, you're watching CNC Garage. Today I'm going to make a kind of a cool little bookshelf of plywood, birch plywood. We're gonna make it in inside a CAD program called Fusion 360. It's a CAD program from Autodesk that is also a CAM program. So we are able to make, sorry, my audio is a little bit high. 1, 2, 3. So we are able to make both the CAD 3D drawing and the CAM tool path for my CNC machine with the same tool. And this is my CNC machine at the moment. It's kind of messy right now, but it's a huge CNC router. It's able to cut sheets of wood, plastic, or aluminium with the size of 2.4 times 1.2 meters in diameter and 20 centimeters height. So it's able to cut pretty large objects. So, and that comes very handy when you are making furniture, because then you want to use the entire an entire sheet of for example wood or plywood in this case, or MDF or something, and then you can make huge objects very easily. So let's just start fooling around a little bit with the CAD program first, and then we are going to go from Fusion 360 and over to the CAM software. Inside the, first we are going to draw it in CAD, then we are going to export it to another program called the Slicer. And then we are going to take that DXF file we get from there and import back into Fusion 360 and make the CAM files, the tool path for the CNC machine. And then probably tomorrow or something, we're gonna cut it out on the CNC machine. And so let's go from all the way from an idea to a real life object this time. All right. So to start this off, I am going to start a new project inside Fusion. I just want to double check that we have our social media with us today. So you can watch this live stream both on Facebook, on the CNC Garage page on Facebook. You can watch it on twitch.tv/CNCgaragen in Norwegian. You can also watch it on YouTube if you go to youtube.com and CNC Garage. And we are also live on Periscope and Mixer. So if we get some questions during the live stream, I will definitely try and answer your questions and whatever comes up during the way. And when we do something live, something always breaks. That's how it is. It's either the CAD program you're using, or the stream, or the audio, or the video, or something. But things are kind of starting to work better now than they used to. So yeah. So let's just start off with. This is Fusion 360. It's a very nice CAD program from Autodesk. You can download it from autodesk.com, I think. Probably. It's both a free and buy program you purchase. So, and I'm currently, if you can see, it says startup license there. And that's because the startup license is free until you make more than $100,000 per year or something. Then you kind of hit the limit on what you're not doing it for free anymore. You're kind of making money of it, and then Autodesk wants some money too. So that makes sense. But I'm just doing this for fun. So let's start a new project. We'll start this off. I really want to create this with a form. It's called a Sculpt function inside Fusion 360. You can either draw it traditionally with make sketches and then go to 3D from sketches with technical drawings if you have millimeter precision or blah 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 blah. But this time the only thing I really want to take into consideration is the size of my shelf. I don't want the shelf to be, it's going to be a bookshelf on the wall, so I want it to be maximum of 80 centimeters height. So we'll just start with that. Hang on, 80 centimeters, 80, come on, 80, and then we'll go probably a little, maybe 100, that's a big one. Yeah, let's go 80 to the sides as well, so it's going to be a perfect square. Oh, something went wrong here. 80 centimeters, 80 centimeters. So we have our dimensions set up now. So we are able to decide at a later stage as well what this object is going to look like. But for now, just let's keep it at 80. So I'm going to use a Sculpt tool called Create Form. So and then I choose what I am going to draw inside. Now I am going to make a let's make a let's make a plane first. 2-point plane. I'll just, looks like I'm having some hi Reese, nice to see you on the chat. So if you just joined, today we are going to make a bookshelf. We are going to use Autodesk Fusion 360 for the CAD, and then we're going to export an STL file into a program called the Slicer. It's also an Autodesk plugin, and we are going to make a plywood bookshelf. So now I'm going to make a plane. I'm going to draw inside that. It's 2 points. So I'll start at that one end and stop at the other. And I really want this to be, for now, just 2 faces each way. You know, faces are this little squares you can see there. You can have more than 2 faces. And I really want to make a body of this, and then I want to extrude. So now I'll go to extrude. And actually we could, yeah, let's do this another way. Let's make a box instead. Same principle, 2 point. We're going to draw that way, from that corner to that corner. Reese, yes, I just started the stream. It's just 1 minute ago, so I just talked a little bit about what I'm going to do today. So we are going to make a bookshelf. Let's find a bookshelf that's kind of similar, so you can kind of get the idea. Hang on. I'm kind of inspired of these kinds of structures. These are very nice bookshelves. They're pretty easy to make because they're made of interlocking sheets of plywood, so you don't need any screws. You can see in these drawings that they just slide into each other like puzzle games. So it's kind of a nice cool thing to make with a CNC router. And yeah, this is definitely made within the same program, probably the same way as I'm going to do it today. Yeah, you can see these screenshots are actually from the Slicer tool in Autodesk, so they're basically doing the same as we are doing right now, except they're actually paying for it. I'm not. So let's start off with, for example, a box, or I really want to have something. With beveled edges. Just I'm just looking for a tool here. Yeah, let's go back to the first way of doing this. So I'll just draw a box with 80 by 80 centimeters wide, and that's, for now, that's going to be the size of my bookshelf. I made a plane inside that sketch just to keep the dimensions. And now I'm going to extrude that plane into a box like that. And I really want that to be maybe no more than 50 centimeters in depth, because the bookshelf is going to be at the deepest point is going to be 5 centimeters from the wall. So, all right, I'll just extrude that, something like that, and let's close up this hole. So we just select this and do one of these. I had some trouble earlier with one of them. So it's a closed box now. And let's go to this side and maybe do some cool stuff. Let's do bevel edges maybe. If we can do that inside merge edge. Bevel, there you go. So I want to bevel these edges. The Sculpt tool is the tool I'm the least familiar with in Fusion. So this is a very good practice anyway. Let's see if we can find a way to bevel these edges. I know another way, but we can see if we do like this and edit form, and if we now scale this, it's really not doing what I want. I tried this an hour ago and it worked perfectly. That's how it is. There's always something. That's how I did. So I should really go back and before I extruded it. So I went like this. I'll just extrude it a couple of millimeters first, so I kind of get the spacing from the wall before I start the curve. So I'll go just for the fun of it, just like maybe 5 millimeters, like that, and then I will close up the back wall before I continue, because that's gonna make some mess. If you have a form that's not closed up, when you try to export it, you will not be able to. So I will fill the hole and I will select the back wall, and I will do some sort of collapse maybe. Yeah, that will work. So and now I will take the front wall, I will do an edit form, and I will push the center point of the sculpt out to get the curvature I want. And I'm looking for the biggest movement right now should be, so it should be 300, should be like 450. It looks a little bit too much. Yeah, let's just try that for now. And to get this to be a little cooler than just, or for now we can actually just export this as is and see how it handles up with inside the slicer. Hopefully it will work. So I will make a, where's this body? There it is. Oh, it's not. Looks like I need to conform this. Looks like it's two different bodies. All right. Let's just try another time and close up the back wall then without that extrude. Fill hole. Just have to check that my Facebook chat is actually showing up as well. Having some trouble with that today. So we are definitely live on Facebook, but there's no chat right now, but I'll just share this around it. Yeah, hopefully I will see if there's any more questions during the stream. I really want to close this, but I wonder why I can't. Maybe I can do it now. So when I tried this an hour ago, I struggled a little bit with the same, but it kind of worked then. When you do these kinds of modeling, there are better tools than Fusion, because Fusion is really made for technical drawings and sketches. It's really not made for soft modeling. As you can see, it kind of messes up pretty fast. So edit, form. So, and let's go 45, maybe 50 centimeters. Let's go 50, yeah. So, and then let's close up the back wall. Fill hole. Fail to fill hole with a given edge. That's interesting. Is that because the sketch is also visible? Maybe. Fill hole. I turn off the sketch. No. Still the same problem. So this is weird. So let's start over. Let's start with the sketch. Let's create a box, 2 point. Select which these yellow boxes tells you which plane you are going to draw on, because you can only start on one plane. So I'll always start at the front plane, because that is how my CNC machine is set up. So, and then I can kind of adjust this one, and I will do that 50 centimeters, 500 millimeters, like that. And I will just try to clean up the back wall. Let's make these edges hard straight away. See if I go, I can just select all and go, oh shit, I missed it. Let's just try this and go flat, flatten, 9 selected. Okay, nothing happened. Interesting. So I'm using the crease function instead. That will give me a proper flat back wall. Looks like. So now I'm almost there. Now I can just work with my design to kind of give it a little more cooler look. Something like that maybe. Yeah, let's just see how that turns out before we go further. I need to save the project before I'm able to export the STL file. You know, STL files are the same that you use for 3D printing, so you can use all of these things I just did and do 3D printing instead. So let's just call this parametric bookshelf stream. 80 by 80 centimeters times 50 centimeters, I think it was. So, and now we go make, and then we go slicer. You have to download this slicer tool separately. It's available in the plugins page on Autodesk. You can see, you will find it somewhere. So go make slicer, and then it basically generates an STL file with these settings, and it opens up the plugin, and hopefully it will import it properly. Yeah, like that. So, and the first thing you should really look at is on the left side here, you can actually see that it's the size. It's actually trying to scale it as a default, and that's kind of dangerous. So we're gonna keep the original size, and we're gonna use it in centimeters. 800 centimeters. That's a huge bookshelf. So let's go millimeter. 800 millimeters. Yeah, that looks more right for us now. So we have our shape. It looks kind of boring right now, but it's going to be much more awesome very soon. So, and the next thing we need to do is during manufacturing settings, you can construct a manufacturing setting that chooses the size of your material, the size of your sheet, like a wooden sheet for this CNC machine I have over here. It has a work area of 2.4 times 1.2 meters, so you can actually put a plywood or MDF sheet of that size directly onto that machine, and you can set that up in the software here. So we'll do that now. So we'll say 2,400 millimeters. That's the same as 240 centimeters or 2.4 meters. Reese, I'll probably mill it tomorrow. As you can see, my CNC machine is kind of full of other stuff at the moment. So I need to clean it up, and I need to put in a large plywood sheet, and I'm definitely not finished with the software part for a few hours. So well, I'll probably mill it tomorrow, hopefully, or the day after that. I'll try to let you know. So 2.4 meters times just under 1.2 meters. And the thickness of the plywood sheet we are going to use is 12 millimeters. And that's pretty important because that kind of decides how big the slice in the interlocking slide is going to be. And then you have the tool diameter, and I'm going to use a 4 millimeter bit to carve out this, and then I'm going to save it. So now this slicer is ready to do some work. the first thing it tries to do is to slice everything sideways. And this is very cool if you have a furniture that you want to make with, let's say you put spacers between all of these layers. You know, these are layers. I can show you. So you can see all of the layers going off. And you can see the blue lines in the top. That's where you can make some holes, for example, for either a rod or a wire or something that holds all the interlocking slices together. So Reese, I'm downloading a numeric CNC simulator. I will try to do something here. Cool. Feel free to make a drawing of something in the, that I can CNC out or something. That would be cool. So interlocked slices, it's what I'm going to use. So you kind of see where I'm going with this. Now it starts to look like a bookshelf, right? It's still way too much space. This is probably good for holding pencils or something, but it's really not good for... It's a very structurally good design, but it's horrible to place books or DVDs or anything inside. So let's go down on the slices. Let's go to 4x4 or something, 4x5, I don't know. Yeah, try to write some G code. That would be awesome. So these slices, now it's looking like a bookshelf, right? So apparently, if you see on the right side here, you can see that it's using 2 sheets of plywood to mill out 8 parts. And those 8 parts are now ready to be interlocked. Interlocking is when you kind of, if my one hand is going like that and it has a slice in it, and the other hand has a slice the other way, and they kind of fit, and then it's rigidity. It's very rigid, and it's you are able to mount it without using bolts or screws or anything. So as you can see now, this is the instruction manual on how to assemble it. So you start with that slice and that slice and that slice, and you can also, this is cardboard where you can see the plywood version. This is very close to how it will look like when it's finished, because I'm going to use birch plywood, and that has a very similar look to this. And you have a good question. It's very feng shui, yeah. It will be mounted onto a wall, and that's the last part. After I'm finished with the design, I will have to take these DXF files on the right side here and put those back into Fusion 360 the hard way. I have to import the DXF, and then I have to extrude it all over, and then I have to draw all the holes for the mounts, because this program is very, it's only made to do one thing, right? It's made to slice up your 3D objects into sheets. It's not made for CAD drawings. It's not made for CAM. Its only purpose in life is to slice up things in very cool ways. And it does that very well. But it's kind of a... One thing I was really missing when I started working with this was the way to actually be able to send it back to Fusion and keep all the 3D parts without doing it the hard way through the XF. But well, you can't have everything. So this is another shelf. It will be very hard to get to the back back shelf. With the back here, it's kind of hard to reach whatever you want to have in there, unless you want to hide it. In a way, it's kind of nice to hide. You can actually do... You can rotate everything as you want, and if it goes red, then it says, well, we are not able to assemble or mill out this without fucking it up. So but let's go interlock slices, and you can of course you can change where everything wants to be. So we can go by distance. You can... One thing I definitely want this to be is to be milled out in one one sheet of plywood, because one sheet of furniture quality birch plywood is kind of expensive in Norway. It's like 50, well, less than 50 euros, so like 45 euros or something. So if you're going to use 2 sheets of plywood to make one bookshelf, it's gonna get expensive though. 100 euros just in material, and then you have the work time, maybe an hour of milling or something, and then you have the assembly, and probably you have to paint it somehow, maybe a clear coat or paint or a color or something. It kind of gets expensive very fast, but at least you're going to get really the design you're looking for, and that's definitely going to cost more than any IKEA designs. Yeah, custom is always custom. That's exactly. It's you will not find this on IKEA, as at least not this design, and custom will cost more. People are kind of struggling to understand that, because they're kind of so used to pay so little for furniture. So as soon as they starts to talk about making custom stuff, it's kind of, wow, is it that expensive? Well, of course it is. You have to, yeah, at least if it's only a one-off, it's gonna get expensive. You know, the hours you use on making the first part, the drawing, the design, the testing, the prototyping, that costs some hours of money, and of course the material costs some, and then you have the run time on the CNC. But it's really getting interesting as soon as you go down to a CNC machine and you start milling stuff out. Then it gets interesting, because then you can make more parts fast, and you can optimize your CNC. You can optimize your CNC machine to go faster. The tool paths can be optimized, and you can rent in a guy that runs the CNC machine day in and day out and make parts and parts and parts and parts, and then you're kind of looking into getting the cost down. So if you're ever interested in making something on a CNC machine, or contacting me or somebody else that has a CNC machine, well, the first part is kind of expensive. But when you're making 10, 20, 100, 1,000, 10,000 parts, then it really gets interesting, because then you are able to get the cost down. You kind of, the cost of prototyping a design and testing it, and yeah, all that, making a CAM toolpath, and the cost of tooling, the cost of setting up the machine, the cost of buying materials, and all of that kind of gets absorbed into the total costs of making a lot of parts. If you only make one part, then at least you have at least half of the, well, probably double the time it takes, the total time it takes to make a part. If let's say it takes 2 hours to draw this thing and test it out, and then it takes a couple of hours to set up the machine, get in the tooling, run the machine, clean it up afterwards, and then it goes another couple of hours of painting maybe, and then packing it down, shipping, all that. That's really expensive when you make one of something. It's almost like it's more, it makes more sense to make one of something by yourself, using your hands and hand tools and whatever accessories you have available, because then you skip the part of designing it. You can just dive straight into making the part by yourself, so you're kind of getting the cost of man hours down. But as soon as you touch more than one of something, then it makes so much sense just to use a CNC machine, a 3D printer, laser cutter, water jet, or whatever, to get that amount of parts generated to make your product. And that's kind of what I dig with this, when you making more than one of something. But making the first one is also very awesome, and that's kind of what we're doing right now. So let's get back to it. We are making a bookshelf, 80 by 80 centimeters. I can see now it's going to get a little bit deep. Let's make it either higher and more width, or to scale it somehow. We can try to use the scale functions inside here. I really don't like them, but we can try them anyway. So let's go width, and let's see what happens if you go down to 45. Looks like we have to write 45. Come on. Yeah, we have to turn off uniform scale. So just need to scale this back to the normal size first. So, and then we go 400, 45, 450 width. And if the scaling function is proper here, they should have a nicer shelf. Yeah, almost. Let's make it a little bit higher. So let's make it, or we can increase the width, maybe. Let's increase the width to 120. That's the typical 1.2 meters. Whoa, 1.2 meters wide bookshelf. It's definitely bigger, but you have a lot of space for stuff. Let's make it a little bit shallower so it doesn't look like a huge something on the wall. So if you have any questions, feel free to ask anything on the chat. It's always cool to hear what you guys are thinking. Today I am live streaming both on Facebook, Twitch, YouTube, Periscope, and Mixer at the same time. So yeah, hopefully I will be able to answer your questions no matter what channel you're on. So this looks interesting. This can be mounted two ways, right? There's no up and down on this design at the moment. It's only a shelf, right? You can, if you want, you can have it sideways, or if you want, you can have it vertical. Come on. Oh, there you go. Kind of looks weird vertical though. Maybe if we decrease the width a little bit, then it works much better both ways. Let's go 100 centimeters. So that onion asks, have you planned any lighting to the bookshelf? No, absolutely not. I haven't, but a very good idea. I do have a lot of LED lighting, but do you have any suggestions on where those should be inside this design, or any thoughts? Is interesting. So kind of still works a little bit better this way, I think. Maybe. You can see, let's move these a little in. Let's go like, or is that cool? Or is it just stupid? Is there an undo button here? Custom by count. So the one thing I'm trying to keep an eye on is how many sheets of plywood I would need, and you can see that on the right side. I really want to keep the cost down. I don't know, is it going to be flush against the wall behind it? Yeah, it is. The inspiration from this design is all over the internet, I guess. It's you can find these shelves on Pinterest and everything. It's something like this, and this is much bigger. I can see, you can, if I would guess, this is probably at over 1 meter high, probably like 120 maybe, and then is it half that size in, yeah, almost half that size, so 60 by 120 maybe. And the depth, how deep is a book? I should have a book here somewhere. I can just measure it out. Then we can probably guess how deep the bookshelf should be. I thought that typical bookshelf was around 40 centimeters deep, but I might be wrong. It might be smaller. 20 centimeters. All right. That looks really neat in action. Yeah, it does. It's a very simple design, and I really like the look of it. And you know, you can make any shape when you do this. When you do this yourself, you can make any shape inside Fusion 360, and then you can adjust it. Well, slice it afterwards. So just let's make it a little bit. I still think it's kind of too thick, you know. So let's try 20 centimeters. Your suggestion. Come on. Oh, there you go. So the width should be 200. That looks much better. It's much smaller now, and it's on one sheet of plywood. I like that. And the width is 1 meter, and the height is 80 centimeters. So let's try out some other sizes. Let's go down to 60 in width, 600, and then up to 1200. And then let's put some more slices into this. And let's have a little look at this one. So this is mounted vertically, and it has 3 slices horizontally, and 1, 2, 3, 4, 5, 6 slices vertically. Let's see if we can do something similar. 3 times 6. And let's have a look at this vertically. We can even try to look at it from the same angle, if that's possible. The orientation of this, it kind of gets messed up. You're not able to view from all sides always, but yeah, it's not willing to let me view from that exact angle, but well, yeah, you'll get the idea, I guess. Come on, why is it restricting some of the 3D spaces? So where did it go? There it is. But you can see this is a more of a perfect sphere. It has a curve. It looks like it's just a slice of a ball. It looks like mine is more of a box with some beveled edges on it. So mine is going to get a little bit fatter, if you know what I mean. It's going to. The curves are not going as far, but I kind of like it. It's very effective. But the other one is kind of, it's not going that, it's going steeper into the wall. You can actually see the curve is ending. The other one, maybe we should just try and do it like the other one. What do you guys think? Is this okay, or should I do something else? You know, we can do some curves, or that doesn't make any sense for me though. So in the direction, This gets kind of trippy. You are able to make a lot of cool stuff that way. So let's see it from the front. So let's just play around with this a little bit. I wonder if I should... Yeah, I stopped wondering now. I decided. So, close. Do you want to save it? No, goodbye. This was another one I played with earlier. So you can have a lot of different types of structures and forms. So let's just make a new one. And I guess that we want to make a 120 centimeters times maybe 60 centimeters. Or is 60 too small? Well, that is not... There you go. I'm just always making a sketch first with the measurements. And if you're smart, you can actually benefit of using... Why is it using millimeters when it's saying 6? So you have a parameter tool inside the Fusion, change parameter, and you can save your measurements. So you will say shelf underscore height and millimeter, 120 centimeters. So, and you go shelf width, and you can go 600 millimeters, and you can go shelf depth, and you go yeah, let's do 25 centimeters then. Just a little bit over what you suggested with 20 centimeters. And you can actually use this inside everywhere inside the drawings. You can go per shelf height, enter, and you can go shelf width, enter. And for example, if you were to make a 3D object of this now, you can go extrude, and then you go shelf depth. The interesting part of thing about this is if I'm always define everything I'm doing. So if I'm making an offset here now, just to make a shelf or a hole in this design, if I do my offset by, for example, 12 millimeters, minus 12. It still did 12. It should do minus 12. Come on, let's do it one more time. Just gonna use some time to show you this function because it's really nice. So my minus 12. Come on. Why doesn't it... Have they changed? I'm really not sure why I can't offset this. Let's try it again. Offset. Come on. I want to offset this solid by 12 millimeters. Okay. Then I make a hole, and that hole should be the shelf depth minus shelf depth, sorry, to be able to cut it. Then I have a hole. So the interesting thing here now, because I used the parameters, the parametric design to decide all of the almost all of the only the offset is constant. Everything else is able to change when I change the parameters. So if I go here and say, well, the shelf depth is going to be bigger, I want it to be 600. And you can see the entire design takes that into account and changes. So if, oh shit, I want this to be 80 centimeters. Cool. I want this to be 200 millimeters. So my entire design is now, I'm not struggling to do all this every time I change the design. I can just go in and type in the new numbers. When your client comes and say, well, we're not able to use 12 millimeter plywood for this material, it's too expensive, or we can't get it, so we have to use whatever we have available, so we only have 10 millimeters. And if you have been smart and programmed in from the start the thickness of your material, when you every time you use the design, then you will be able to change the thickness, and the entire design will adjust to that new material thickness, for example, or a new bit size or whatever. So I'm not going to use much more time on that now, but the parametric design is very, very interesting, and that kind of speeds things up a lot when you do this. So the distraction there, but cool. It's pretty cool. Of course, you have physical materials. You can kind of represent how this will look in whatever. And then you can go render. The stream, I actually have some stream drops. If I render this real time, sometimes the stream drops out. So if it drops out right now, don't freak out. It's just, I'll just try and real time render it. Looks like the stream is stable. So it for every iteration it kind of improves the render, or you can render in cloud, and yeah. But that's really not what we're here for. So I just want to make a let's go back. Just go back to our box. I really want to make a form, and I have to push the right button. Damn it. Create form in that plane, and I want to make a sphere. So new body, sure, in that plane, and we want to center it, so that's center on that plane, holding shift in and finding center on the other. And now I have center both ways, and I'm kind of making a sphere now. I'm wondering how I should cut this out. I haven't done this before, but it's going to be cool, I guess. See if you can see, you kind of see the same dimensions on the sphere that they used to make this perfectly circular shelf, and now we're doing kind of the same. What I really want to do now, I want to make a solid. This is interesting. So let's just finish this and go back into the sketch, and let's extrude that 25. Sorry, let's use the parametric design. Shelf depth. Oh, I need to change that. So shelf depth to come on, hello. So 25. And then I need to move my cylinder back. Let's move it back, so we kind of keep the a little more, too much. That's actually perfect. So something like that. How do I do this? I want to use this object as a cutting tool to cut out that slice. So you have something called combine, and that is actually a cutting tool as well. So you select your target, and that's my target. That's the piece I want to cut in. And then you choose your tool, and this is my tool. And I want to intersect like that, yeah. I want to intersect this sphere and only keep the parts inside that. But before I do that, let's increase the width of our shelf, because you can see it kind of caps off the sides, and we really want the sides. So we have to be able to keep this diameter sphere, we need to increase our width. So let's do that first. So let's do, now we can use our parameter design for this. So let's do shelf width and increase that to maybe 80 or something, 800 millimeters. Should be able to see that instantly. Oh, it's only going one way. Wonder if I can fix that. I haven't centered my box. I didn't fix my sphere to the center of that box. So when I change my dimensions, it kind of doesn't stick, but that's okay, I guess. So let's go 80 centimeters. Is that enough? Let's go 90 then. And let's just move this manually until the box fits. So this is the box, I'll move it. I'll use the move tool. I'll just free move it into, so I made it 90, didn't I? So half of 30 is 150, so that should be center. Still not getting the entire sphere sideways. So let's increase it a little bit more. Or we could decrease our sphere, but that kind of caps it in the height as well. It makes sense. It's a perfect sphere, so it should be as high as at its width, but unless it's going to cap somewhere. So let's go 120 by 120 then. And then move it once more. Yeah, now we're getting somewhere. And let's see the bottom side. Looks good. That looks good. Yeah. This will be awesome. So this is just used as a cutting tool. So we can even call it cutting tool just to make sure. And then we go sphere. And then let's do the cutting. So let's turn off the sketch so that you don't see that ugly frame. So we go combine, and then we select our target. We're going to cut this sphere, and we are going to use this square as a cutting tool, and we are going to not cut because that's gonna remove all of the inside of the square, but we are going to intersect it. So we kind of make a new part, and we make a new component, and we are going to keep our cutting tool. If you don't check that box, the square will actually be removed. So now we can hide our box, and we can hide our sphere, and we are only left with this. This should be exactly what we want. Now we are able to save this, and we call this bookshelf sphere, 120 centimeters. I always try to write down as much information in the file name as possible, so because after a week you kind of forgot everything about what you did there, and instead of looking it up, you can just see it in the file name. It's a good practice, I think. So I don't want to save this. So we have our components. Let's send that to slicer. Go make slicer, and then we select it and make sure we select high refinement, because that's the amount of meshes or details inside our object. So let's have a look at this. We are going to use the same setup that we made earlier. So as long as that's saved, let's just double check it. 2.4, 12 millimeters, 4 millimeter bit, slot offset, sure, yeah, looks good. So let's go millimeter, original size. So Reese, I'm not sure actually. I will probably stream until I'm either too tired or maybe 12 o'clock, 11, 12 o'clock probably. I'm not sure. This will take some time. I'm kind of talking as much as I'm working, so it's definitely taking some time. So let's do the slices down. Oh, we have one sheet now. That's nice. Almost getting there. You can see these outer slices are not, they really should be connected so things don't fall apart. So let's do it some more slices in the height. This is really starting to look like that one. Yeah, be back in an hour. Or if you want to see the cam part of this, I'm really just finishing up the details on this, and the next thing I'm going to do, I'm going to make a DXF file, like a 2D DXF file on the, as you can see on the right side, and I will import that back into Fusion, and then I will extrude all the elements again, and then I will start making the cam process, and I think you're kind of interested in that, so you might stick around for that, but probably half an hour or something. Maybe sooner, or you can just rewind the playback later if you want. Yeah, everything is available for 30 days afterwards, either way, or it's also available on my Facebook page. So if you like the Facebook page, hang on, Facebook. If you go facebook.com/CNC Garage, you will be able to see the entire stream there forever, I think. Or until Mark Zuckerberg changes his saving. Oh, that's the wrong CNC Garage. There's actually more than one. What? Come on. So this CNC Garage. Ah, it's .org, sorry. So CNC Garage, facebook.com/CNCgarage.org. I'll try and put that in the chat as well. You can see everything there later if you miss something. So we have some, it's kind of starting to look like something I would actually put up on my wall, I guess. Would you? Would you have a shelf like this on your wall? Kind of thinking a little bit. Yeah, bye for now, Reese. So we'll go modify form. Actually, we don't need to, because these are now interlocked in so many places that they don't fall off, I think. So structurally, this is kind of starting to look like a proper furniture that is able to hold some weight. And it's probably going to weigh something as well. We can calculate that later. But 12 millimeter plywood. I'm not sure what the weight on that is, but this is within one sheet of plywood, so I don't know. You'll probably always have to mount a piece of wooden shelf properly to the wall anyway. I'm actually considering having this in the living room, if my wife lets me. So this is how it interlocks. You can see it slides. And I want all of this to be dog bone. Do you know what a dog bone is? A dog bone, you know how a dog bone from Donald Duck looks like? Dog bone, it's, come on, dog bone. So, a piece bone from a human being, that's a bone, right? You can see those curves, that's a dog bone. That's why they call it a dog bone. So when you carve out stuff with a dog bone structure, to be able to get all the way into the corner with a round tool is never able to cut a perfect square. Can we agree on that? This circular cup is never able, if I push this hard into something that's shapes after the cup, the form will be a sphere. It will be a circle. It will never be a perfect square. And normally when we design something to fit together, we want things to be a perfect square. But our cutting tool is usually somewhere between a 2 and a 10 millimeter bit that's spinning around fast and milling into the piece of material. And that's why we use something called dog bone. Then you can actually be able to, yeah, this is a dog bone. Well, it's not the best example anyway, but so I'm going to use dog bone to get the all of these slices properly cornered off. You can see, if you zoom in closely here, you can actually see the dog bone. I'm really struggling to zoom into that, but come on, zoom. This yeah, the preview functions on this is not good enough, I guess, but there is some dog bones there. You can actually see that it cuts into the corners, so that when you start interlocking things, they fit perfectly. Ah, there's a dog bone. You can see it curves, it mills a little bit longer than the square corner. So this is the shelf now. It's kind of starting to look like something. So it's able to assemble without using any bolts or nuts or anything. Maybe a little bit of glue would have helped, just to make sure it doesn't fall apart when people start pulling at it. So, but it's starting to look like something. So maybe we should make this in acrylic or something. That would be cool. See-through acrylic. Yeah, anyway. So, and now at this moment, this bookshelf is 25 centimeters deep at the deepest point, and that's probably around here. And it is 1 by 1 meter in size. So you will need a decent size wall to fit this shelf. But in the other end, when this is actually working, you will fit a lot of stuff on your wall. And that's the point of having shelves, right? To be able to store all the shit you don't have any room for anywhere else. So, and if it looks okay as well, that's kind of a nice thing. I guess this is, at the moment, we are looking into a material cost of around 50 euros. At the moment, and that's without painting or clear coating or anything. And we have let's say we used 1 hour to design this. If I were not doing a live stream at the same time, I would probably do this very fast, probably an hour's time. And that's just the prototyping part of actually designing the furniture you want. And the next part now we're going from a CAD environment into a CAM environment. And the CAM environment is when you take, sorry, I'm just gonna switch into the CNC machine in the garage now. So this is a live stream from the garage. This is my CNC machine, and now I'm going to tell this machine how it should carve out these pieces of wood. And that's, yeah, let's have a look on how we're doing that. Let's just save this now. So save it to my computer, and let's put it in a folder. I always use Dropbox for my stuff, so I can. So let's go vlog CAD folder, and let's call this sphere bookshelf 1 by 1 meter, 25 centimeter depth, 12 millimeter plywood thickness, and the most important thing is 4 millimeter bit diameter. And that's because if I change the bit diameter to do something else later, then the dog bones, you know, the holes inside the corners, they will not fit anymore, because then the bit size will be bigger and it will carve bigger holes, and it doesn't fit anymore. It might take off that back part and it kind of get wobbles, and yeah, everything goes to, yeah, not good places. So these are the plans for designing. You can extrude this as a PDF for example, printing out on cardboard and cutting it out on and making it of cardboard. Or you could do an EPS file for if you have a vector, if you want to use Adobe environments, for example, Illustrator or whatever, to continue designing. Or we are going to use DXF, and that's what I use. And that's because most of the CAM and CAD and CAM programs, they like DXF files very much. DXF is a 2D format drawing. It's kind of vectorized, so you are able to select all the lines and extrude things easily. So sphere bookshelf, yeah. No, I don't want to replace it. I just want this to be named DXF. Yeah, I'll just do that just in case. So now we have gone from a sphere, that sphere, or a half a sphere, 1/4 of a sphere or something, and we sent that into our slicer, and now we're about to send it back. So I'll just save. I already saved it, so I'm just gonna minimize this for now. You can see the part numbering as well. It's not that important right now, but it's going to be important when you put it together. So let's just have a quick assembly look before we close anything here. So this is how it looks like from front. It's missing a couple of there you go. So let's do it from the start. So the first thing you place is the vertical left, and then you go bottom horizontal, and then you go from bottom up on the horizontals, and then you continue from left to right on the vertical, and then you take the two on the sides as the end, and then you have your bookshelf. But a good question now would be, how do we mount this on the wall? Well, it's kind of, unless you have a crazy looking wall, this is not gonna hang there by itself. So we have to make some mounting brackets of some kind. I have no idea on how to do that yet, but I have some ideas. maybe. Just make some holes for some mounting brackets if we can find some, and let's put them on the. Let's put them where they are not, the least visible from when you view this. So when if you hang this on the middle of the wall and your wall is at least 2.4 meters high, the half of that is 1.2 meters. So if you center this on a normal typical living room wall, it will hang 1.2 meters from the ceiling and 1.2 meters from the ground, and you will kind of, if you're a normal person and you have, I'm 185 high, so I will probably see this from a little bit of an angle from the up down. But if you're lower, you're probably going to see it from low side. Most people, I guess, will see it a little bit from the top. So let's place our mounting brackets on the bottom side, because you're going to use the top side of the shelf you're going to use the top side of the shelf to place stuff in, books and whatever, so it's kind of stupid to have mounting brackets on that side. And also, if you mount the mounting brackets on the bottom side, the entire shelf will lean on that. If you make an angle, 90-degree angled some kind of mounting stuff, and you put that on the entire shelf will kind of lean on that. And if you have enough of those, maybe if we do, let's do at least do the center one. What's the center one? There is no center one. It's two center ones. So we should do the top one probably, and then the bottom one. Is that enough? And let's mount it. Yeah, I do have a 3D printer, and I think let's see where I have it. Let's see if it's on. Oh, it's dark in there. It's not on right now. It's in another room, and it's so dark there, so you can't actually see it. But yeah, I do have a 3D printer, and I could print this right now, but I clogged up the nozzle on the 3D printer with some plastic the other day, so I have to clean it first. But this would be a nice thing to just scale down and 3D print, I guess. Scale down to 1/10 of size or 1/5 or something, and then print it and see how it turns out. But you can see that pretty well here as well, how it looks. Yeah, so let's go further on. The next thing now, unless they have changed it. No, you haven't. You could print custom brackets to bolt it to the wall. Yeah, definitely. And I've done that earlier, but ABS and PLA plastic, it's really not good enough to hold that kind of a strength. So you really need something a little bit more structurally reasonable. I think I have some IKEA type aluminium brackets here somewhere. Yeah. At some point I would really want to find those before I continue making the holes for the brackets. I need to go into the design. So let's go back. So where's my fusion? There's my fusion. I will make a new project, and the reason for that, because now I'm going to import the DXF file back into Fusion. So I will make a new design. I will make it 120 centimeters wide and 245 centimeters high. Something is going on this. Every time I type this now, it kind of overwrites my whatever I type and just pushes M for meters. I really don't know why that is happening. I haven't seen that before. 245 centimeters. Come on. used to work. I've never done that before. Oh, this is annoying. So another reason to use parameters, right? Apply height 2 and 400. Apply width 120. That's the size of my CNC machine. So, and apply thickness 12. And that is important because when I go out in the garage tomorrow or something and I measure my my material, sometimes the material isn't actually 12 millimeters or whatever. It might be 11 or 10 or 13, or it really depends on the manufacturing process and each batch of material. So it's really nice to change this parameter when you know what the material is. So and I go bit size 4 millimeters. This is a really nice way to look up on your own design if you forget something. So apply height, so, and then we go apply width. So this is a sheet of plywood, right? To be even more cool, we can just add something like a pine look to it or something. Oh, I need to extrude it first. So let's extrude that to add apply thickness. Oh, that looks ugly. It's definitely that not. So where is birch? Yeah, that's better at least. And now I am going to call this body my stock material, or just a stock, and that's a term of calling the piece of material that you are going to carve into with your CNC machine. So that piece of material is going to go up on my CNC machine, this one, and it's going to be carved out when it's ready. It's probably not going to be ready today, but we'll see. Maybe have probably an hour's worth of cleaning the garage before I'm ready as well. I have to get the plywood into the garage. So next thing is importing our DXF file, and then I will select the body or the face of the body I want to import my DXF file to kind of make it go inside that, and hopefully it will go. Sometimes it doesn't. So select the DXF file, and then I will find my, it's already there. This is my DXF file from my slicer. And now it's thinking. So it's kind of working now. So you're just gonna let it work. I'll just get another cup of coffee. And it looks like the file has been imported now. And it's millimeter precision. It's a single sketch. Yeah, everything looks good. But I don't want to have with me is the annotation, the numbering on that. I really don't want to mill out that, so there's no reason to. I don't want the frame size, but the rest I do want. So now I'm just gonna let it work while I get my coffee. Thank God for Siemens coffee machines. One button and you're all coffeeed up. So, right now we have gone from this design through this design and back to this design. Does it make sense? Do you have any questions? Feel free to ask anything on the chat. It's always cool to hear what you guys are thinking. Yeah. So if I would, maybe I would, I could either extrude all of these elements and make a new 3D object with all of these parts inside Fusion to continue working on the design. Or I can draw the holes for the mounting. I think actually for this prototype, I really don't think I should design the holes for the mounting plates right now because I don't have those yet. So it's, I guess it makes more sense to, it makes more sense right now for this prototype to just leave it without mounting holes and then just try out a couple of few different mounting fixtures, and when something works, then you can go back, put in those holes here, and then you can make many shelves. You can make a lot of these in a very fast. In a day you could probably make 10 or something. I don't know. It all depends on how much time it takes to carve out. You see there's some space left here for other stuff. We can do some other cool stuff with that. Just for the fun of it, we can import another. So SVG file into there. Oh yeah, sure. And I really want my, where did it go? There it is. CNC garage. We can carve out that in over here maybe. So let's just flip it 90 degrees and move it. Just to use our plywood. It's much easier to use the entire size of plywood when you have it all on the machine at once. If you always end up with a lot of garbage or debris after you made anything, and this space is not used for anything, right? So it's kind of just dead space, costs money, and it's just more trash. So to be able to have a few designs laying on the, just laying there until you're ready to carve out something of a piece of plywood or whatever, and then just import all the rest of your designs and just do everything at once. It's much more cost effective and much less garbage. I'm really not sure where I'm going with this logo. I really just want that part. So let's see if I have that separately. I think I have. So SVG Vector big. Let's see what this is. Oh, it's the same. But is that with the text? Oh, so the text is separate, so I can just... Alright. Yeah, but no, I'm not able to move it, so undo, undo. Let's do it all over. Insert. So which one did I choose? This one. Just scale it up a little bit. Move it. Move it over here. There's a lot of space over there. So if I should make more than one shelf, it looks like I'm able to put more than one shelf in one piece of plywood if I stock this a little better. If I flip this around, it can go next to each other, and the next one can go on the half curve of that, and you will probably save a lot of space. But for now, I really don't care. I just want to do some cam tooling. I'll just stuff that somewhere over here, I guess. For now. Okay, and then we'll just delete the text. So hopefully all of these vector files are not broken. You never know that, because sometimes they are. So just let's just have a double check this. There's two up there. Oh, you're not seeing the screen anymore, sorry. So you have two of these. Yeah, it looks like one of these there. So two of these there, and you have one of these there. Yeah, it looks right. Do I have a drone on my shelf? I have a lot of drones on my shelf, actually. Which one? Think about this one, or this one, or this one, or... I can go on for hours. This one is a pretty cool one. This is a racing drone. This goes incredibly fast. This is a 4-cell racing drone. It's a 210 frame, so it's 21 centimeters behind from space to space. These ones are pretty cool to fly indoors. My cat loves these. This has a camera in front, and this doesn't, but yeah. So, oh, I scared my cat now. So the hello. If you want to say hello to my cat, you can. She's all the way down there somewhere. Oh. We're not able to angle that camera further down. Cat cam. She loves playing with these drones. Yeah, let's get back to it. Yeah, you're not supposed to eat it though. So let's get back. Yeah, the black one, that's the racing drone, that's correct. So it looks like, in terms of cat size, it's, yeah, something like that. I have some bigger ones as well. I have a DJI Phantom, and I have, where's that huge one? This one is a bit bigger. So this, the legs here are actually CNC machined. You can see, where's that camera, damn it. So these legs are designed inside, I think it was SketchUp actually. And they're milled out in 4mm of plywood. And the frame is as well. And yeah. that hasn't flied for a couple of years because I only fly the smaller ones now. You have that IKEA chair, great, but you don't have that many white hairs that I do on the chairs because of the cat. So so let's stop this sketch and go extrude something. Actually, we don't really need to extrude it, but just for the fun of it, just let's do it anyway. So I'm going to choose the bottom side of my there, and I'm going to make a new body, actually a new component, and this is my new component. That's that one, right? Are you with me? And then I'm going to do the same for all of the other ones, just for the fun of it. So I'm going to do extrude, select the bottom. I can just type -12, but it's the same. Select the bottom, and it will create the thickness of the, you know, I should really not do it this way. I should really do undo and do it all over with the parametric design, because that's the proper way of doing it. Undo, undo, undo. Yeah, there you go. So, and let's just deselect this. Just go select these. Come on, this. No, not that one. This is bugging out sometimes. And this, and this. Yeah. And this. This is one of the reasons why we use the XF files, because the XF files actually do have closed designed, just like a vector file, like a SVG file or something else. So let's just do E for extrude, and then now the interesting part. Then we use the ply from the parametric design. We use the ply thickness. And so if I change in my design up here, the ply thickness, then all of these will actually change as well. The only problem I will run into is that the thickness of those slices are actually drawn inside the slicer and not inside Fusion, but everything else should be alright. So let's just do it like that now. And then I probably have to type negative instead of positive, because it's not going to, it's going to lay above my stock plate if I go positive. So it should go minus ply thickness. And then, hello. Yes, snart. And then I do new component, and then I do OK. And now it's either going to make one big new component, or it's going to make like 15 new components, hopefully 15 or something. But it made one. Well, I can split that later, because there's a lot of bodies in here. I can just make components, just right click, create component from bodies, and then you have the entire, yeah, but we really don't need that. So what we just did, we made all of these parts from a 2D file and back to a 3D file, and now it's kind of getting ready to be worked a little bit with the CAM toolpath. I should really move these two down here so I kind of get all of this plywood to spare for something else. So let's do that. So where are those? I really think that Autodesk should work on the optimizing of their placing of this. If I do like that, I can just flip it around. It kind of fits perfectly in there almost. Just have to, the space between those two materials have to be more than 4 millimeters or they will cut into each other when the tools come passing by. So that should be good. And that's the last one. That's body 10. Let's move that down here. And let's reintroduce the stock material so I don't put it outside of my material. And it should be at least 4 millimeters, 325, 6, all right, yeah, it's okay. It's better to have a little more than too little. So now it's kind of getting somewhere. So this is body 12. I'll move that down here if I'm able to. It's kind of getting a little bit close. Let's just rotate it a little more maybe. This is just like playing Tetris. You just have to kind of optimize the space you have without compromising on the structural side of when you start cutting a lot of holes, a lot of stuff into a piece of wood or whatever, you kind of at some point the entire sheet will collapse and just be destroyed, and it depends on how you mounted it to the CNC machine, but I use a vacuum table so it kind of gets sucked down, but when you punch enough holes through that plate, the suction of the vacuum doesn't hold the sheet in place anymore, and then it just comes loose and then it makes a lot of mess, breaks everything, and probably kills someone. So you really want to make sure you also have clamped it down with some physical bolts as well as a vacuum. But this looks okay for now. And now you can see that we kind of optimized. We have a lot of sheet material left here so we can use for something else. And I could do this for hours and optimize. There's a lot of empty space here that we could use. Probably even could fit that one almost. If we just slide the other ones a little bit down, maybe we can... where's that one? Body 8. We could just push this maybe down there. And then we have even more space available. So there's the edge, 193. Yeah, this should do it. Yeah, we'll see that when we go further on with the CAM process, we can also see that if the bit is crashing. So that is body 10, move body 10, rotate first, and get it in there. Yeah, just in the middle there. Perfect. Maybe that looks a little bit too big, but we can try. Body 5. Let's rotate and move. So 485, no, sorry, 486. There's enough. Yeah, should be enough. Cool. Even more space, more material for other stuff. You see, if I would have made more than one shelf, I could probably easily fit at least half a more shelf on this plate or sheet, and then on 2 plywood sheets I would make maybe 3 shelves, and then that gets costs down a lot, right? So the less material you use for the more amount of components, then you kind of get the cost down. You can sell things cheaper. And we always like to get things as economically, as good as possible, and not throw away any more material than we absolutely need. Because both of the environment, the cost for the customer and for yourself, and there's actually a lot of pain in the ass related to removing the material from the machine, driving the material down with a. I have a on back on my car. I have a hanger. What do you call that? Yeah, like a hanger on the back of the car. You put all the trash on it and drive down and actually pay money to throw that away. So there's costs, time, and environment to try and keep the amount of waste material down as much as possible. And that's always nice to think about. So this is kind of starting to look like something. We can still work this out for a lot of more time, but for now, let's just save this into, let's call it sphere bookshelf, 12mm plywood, cam. Let's call it a cam, because that's when I start looking for the cam files, when I have to change something, the feeds and speeds or whatever. So the next thing I'm going to do now is create a setup, and then this is where you tell the CNC machine what to do. So I'm going to make a setup now, and I'm going to tell this setup that I'm using a solid, and I'm going to find that solid. Come on. So where is my stock material? There it is. So I already defined the height, the width, and the depth of my material when I made the stock body, and now I'm using that stock body as a default setting to define the outer spaces of my CNC machine working area. So that kind of helps me out a little bit. So, and the next thing I need to do is set my coordinate, XYZ coordinates. Right now it looks good. X is going to the right, Y is going backwards, and Z is going up and down, right? And I'm going to make the offset in the bottom left corner. So that's everything I need to do to set up the machine, the machine CNC setup, to be able to start working on the material, on the components. So I will probably, this looks like a very nice routine for a pockets tool. You can either go to the tool paths, and then you have to select all the outer or inner lines of what you want to mill out. I can show you. Or you can do 3D active toolpaths, and that is a different way of thinking. Fusion 360 is then you're not going to select all of the material you are going to carve out. You're only going to select with 3D toolpaths. You're only going to select what you don't want it to carve out, because it's doing some smart algorithms to try and do most of the brains for you. Unfortunately, that's not always the best solution, because then it works out the fastest way of doing it and not the smartest, because sometimes the parts came loose and blah blah blah. So let's just do 2D contour cam toolpaths for now. The first thing I'm going to do, I'm going to set up a 4mm end mill. That's what I'm going to cut this with. I'm going to go down to 4mm, and we'll just leave the feeds and speeds for now. We're just going to select all of our what we are going to cut out. So we are going to cut out this and this. And I always select the bottom contour and not the top. This is the top one and this is the bottom one. If I only select the top one, it doesn't go into the material. So we have to go for the bottom one. So this one, this one, this one, and this one. And let's maybe just leave that one for now. Oh crap, I just canceled all of it. Let's do it all over. 2D contour, select tool, 4mm, and then let's do all of these bottom ones first. So we can turn off the vacuum on that side of the plate when it comes loose. So what happened there? Actually selected. So I selected OK, and you can see the blue lines are where the tool is actually going into the material and going around it. And you can see there's two blue lines over each other, and that means that it's going to do two passes. So it's just going to be a little shallower pass first, and then when it's finished with that, it's going to go down another pass. And so on. Let's just duplicate this. Wait for it. You can see while I'm waiting for the duplicate, you can see where I have my mouse, you can see this, it says T1 and says 31 colon 12. So it's 31 minutes to carve out these ones. And that's before I worked, defined the feeds and speeds of the machine. So I'm really going to optimize the speed it takes to do this afterwards. Just waiting for the machine to think. I really have to just check something. I'll be right back. Oh, I'm on my way back now. Just had to check something. So we duplicated the toolpath, and now we're going to do the second come on. I don't know why, but I can see that Fusion is kind of struggling right now. Just gonna make sure I save it. So Fusion is a cloud-based software, and it has some positive and some negative sides to it. So so let's continue and do all of these. This one, this one, this one, and the inside one of this, because this is going to, yeah, let's do this entirely separately. If you carve out the outside of something before you carve out the inside, well, then the material will come loose from the CNC machine before you are finished with the object, and then you kind of destroy your material or your bit or both, and yeah, it kind of gets it gets messy very fast. So you really have to kind of think of these things while you're doing your cam profiles, and that's what I'm doing right now. So I'm planning on doing the bottom row of material first, and then the tree in the middle there, and then I'm probably going to go further on to. I just want to save this now because I can see that for some reason I'm using a lot of resources on something. My machine is it's a properly spec'd machine. It has like 64 gigs of RAM, and it has a Intel i9 CPU and a Titan X graphic card, but still Fusion is kind of struggling sometimes. I don't know why, but I'll just try to keep the amount of processes going on at the same time to a minimum. Just gonna close some stuff here. Of course, when you're doing video streaming at the same time and maybe have a lot of other programs running, everything kind of sums up and eats resources. So trying to kind of cut down on what you need and what you don't need while you work kind of saves you a little bit of working time. So I'm going to continue now. I'm going to duplicate once more, and this hopefully will go faster, or maybe not. Just waiting now. Maybe I should stop using the duplicate button because it's probably faster just to make a new preset and just load the tool afterwards. I've never seen it used that much time before. So if you just joined, we are making a parametric type bookshelf with plywood. I'm going to use a Norwegian type plywood that's very normal to use in these types of furniture, called birch, eller bjørk in Norwegian. I have bought maybe a truckload of those, so it's nice to use them. So let's select the inside of this first, so the material doesn't come loose before you're finished. Only the insides, come on. There it is, and there it is. And when it's finished, then it's okay to carve out the outside. Still waiting a little bit for the next tool path to finish. I have never seen it used that much time before. I wonder if it's a bug, or if it's a resource leak, or if it's because I'm using livestream at the same time, or when I'm only using 30% CPU and as like not even 4/4 of my memory, so that's really weird. Maybe it's just a bug within Fusion that does this. So, and let's see if we can go faster. 2D contour, 4mm. Yeah, sure. This one looks, yeah, this goes faster. So, and then do the outside contour. Yes. You can, if you look closely, if you have a full screen video up and running, you can actually see the times being calculated real time on this where I have my mouse now. You can see 31 minutes for the first, 10 minutes for the second, 10 minutes for the third, and right now it's calculating the amount of minutes for the fourth operation, the cam operation. The blue lines are of course where the CNC machine is moving. Still waiting for it to finish. God damn it. It's finished. 3 minutes it's taking at the moment to run around those objects. And then we need to carve out the top 3 ones. 2D contour, 4mm, yeah, sure. Then we need to select what lines to carve or to mill out. The 3 top ones. It's the only ones that's left, I guess. So now it's calculating the tool path lines where the tool is supposed to go inside the material, and then it's calculating how much time that takes. And right now we're looking at around, just a quick look, 31, 10, 10, 3, so it's like 23, 30, it's like almost an hour. You can always add some more time between this tool pass, because the machine has to move between those operations, and sometimes things take a little bit longer in real life than they do in the calculations. Sometimes they take a little bit shorter, and sometimes you make some adjustments while you run the machine in the garage, and you see that, well, this would have made more sense. It would have made more sense to run faster feeds or faster speeds and blah blah blah. So it's just a calculation. It's just not the optimal time. So now we have done what we want to do. So let's show the stock material again. What we can do now is run a simulation. You know what a simulation is? It's when you, with the software, try to simulate what you're doing in real life. So this thing is the bit of the CNC machine, and we just want to see the flute going down into the material at this point. I'm gonna make it transparent. We're gonna turn off our tool path, and we're going to make our stock look green, so we kind of see it much better. The first thing it does is go around this one, and I'm going to speed this up because this is kind of boring to watch. So this is in the order what the machine thinks is the optimized way of doing it. I definitely not agree on that. I think it would have been much faster to go from one side to the other, but well, it's just a few minutes difference, but it makes a lot of sense if you're making thousands and thousands and thousands of these. If you're only making one and you are doing it on your spare time, it really doesn't matter if it takes 32 minutes or 33 minutes, but in case of a customer asking, of course every minute counts, so try to optimize everything all the time. So 1 hour and 18 minutes apparently it takes. It's 5 operations, and it removes around it removes around 4% of the volume in size of dust, and that is not that much dust actually, but so it looks good. We still have a lot of space here for making something else, so maybe we should do some more thinking before we start milling. Maybe we should draw something else tomorrow or something, or later, and just fill up the plate, make some more cool stuff in plywood. So let's try and optimize this. We could see that it took almost 1.5 hours to do these operations. And that's before I started calculating what's the best feeds and speeds and all that. So we are going to do some math now, hopefully, if my applications is still working. There's a lot of good calculators online and on iPhones and everything that you can use to calculate the optimized feeds and speeds of your machine. The RPM of the spindle and the feeds for the machine, how fast it should move according to the spindle and according to the material you're cutting. So looks like my favorite application doesn't work anymore because of the new iOS update, and that sucks. So I got another question on the chat. Hey, did you custom build your CNC? No, I didn't. I ordered it from China and it arrived in a huge box with a mobile crane. And it looks like this at the moment. That's the CNC machine right now. It's kind of messy, sorry about that, but yesterday I was working on some other stuff, and you know how it is. It's definitely not that doesn't work. So it's definitely not home built. It has a 3 kilowatt spindle. It has a 5.5 kilowatt vacuum table, and it does have huge stepper motor controllers, and I have a vacuum table of a vacuum cleaner for the dust, the debris and all of that, and that takes around 3 kilowatts. So when this machine is running full speed with everything, it kind of uses about 12 or 13 kilowatts of 230 volt power. And that's a nice power usage for a home garage. Yeah, it's good quality components. You can actually see on the live stream. You can see the fourth axis right behind that green drill press. You can see a fourth axis that's 1.3 meters long, so you can actually carve out fourth axis stuff. Sorry. Yeah, it's Hivin rails. Yeah, it is. I ordered it with the Hivin, so it's probably Chivin as a Chinese version, but it's still the same square type rails. Yeah, it looks good. It works good. It actually has an oil dispenser on the back of the. Let's see if you can see it. Maybe on the back side of the x-axis on the left there's an oil dispenser for all the linear rails. So every time I push that pump, it pushes oil into all of the linear rails, and that's nice. So let's get back to optimizing this. What we have done, we went from a design inside Fusion with a sphere, and we put that into a program called Slicer, and we slice it up, and then we imported back the DXF files, and now we are making a bookshelf in plywood. Yeah, it really sucks to manually grease your rails, yeah. But I still do that manually from time to time just to make sure, so nothing gets rust on it, because everything corrodes easily, especially those China steel things. So, feeds and speeds. If I remember correctly, I can run around 18,000 RPMs with 3,500 millimeters per second for a 4mm bit. I will do the math later on, but right for now we can just use that as a default. Actually, we can set that up in the tool itself, so we can apply it to all of the. So 18,000 RPMs are the fastest speed on this machine, and the fastest move feed is 5,000 millimeters per minute, but I'm taking it slow because it's a tiny bit, and when you move fast with a tiny bit, the bit bends, of course. It resonates, and that makes not of a clean cut. So I'm trying to make a clean cut for a furniture, and that's why I'm kind of keeping the speeds down. So I'm actually considering doing it even slower than that. So let's do something like this for now. Plunge speed is around 800. I'm not plunging anywhere anyway, so when I'm finished. And it's just a 12 millimeter sheet of plywood. Are you using a downcut spiral bit? No, I'm using a normal, not an upcut and not a downcut, just a straight flute for this. So I'm not sure I have a straight flute right here right now. Maybe in this bag, actually. Oh. So this is just for demonstration purposes, for not everybody who knows what we're talking about. So this is a 10 millimeter end mill, and this is an you can call this an upcut bit, because when you turn this clockwise, it pushes the material upwards, and that kind of also pulls the material. Every time you turn down into it, it pulls the material up, and that kind of sucks when you are trying to hold something physically down until the machine table. So that's why sometimes you use upcut bits to get material out of deep spaces and such, and you really have to struggle to keep things locked down then. And sometimes you use down cut bits that do the opposite. They pushes the material down into the floor, not the floor, the machine, and it kind of keeps the material locked onto the table. But for this, I'm going to use a straight flute, 2-flute straight bit, 4 millimeters. So it's not pushing either up or down; it's just staying there. And then you just have to make sure you remove all of the what do you call it? The spoon. Yeah, all of the debris. You have to be removed somehow during the process. So let's continue. I'm considering using tabs for this because it's a furniture. Takes some time to manually remove that later and push it down. So another question: do you machine much aluminium on your CNC, or mainly woods? This far I've only used aluminium. No, sorry, I haven't used aluminium yet. I'm going to do that. But at the moment, mostly wood and plastic, actually. You can also, if you check this out, YouTube. If you push the link in the Twitch YouTube link there, youtube.com/CNCgarage. Then you can actually watch some of the videos while I mill a lot of plastic, and that's pretty cool because plastic is very fun material to work with. It's actually HDPE plastic. Actually, I can show you, so you don't have to find it yourself. But remember to click subscribe.
I love diving because it gets me out and.
So check this out. This is the live stream right now. Let's check this out. Look at this. This is a 4th axis operation. That's pretty cool. This is actually the same 10 millimeter end mill I just showed you here. being used on wood on that 4th axis. I'll just go a little faster. This was like a 3-hour operation. First I used a 10mm end mill, and then I went back with that's a 4mm upcut ball nose mill, 2mm radius, and went back and forth and back and forth and back and forth. And after a while we ended up with a very nice looking woman. Actually 2 of them. I made 2 at the same time, so you just divide them in the middle. And so, but there's some plastic here as well. If you just go videos, come on. Yeah, right here I'm making 90 something, 96 or something prototypes of this in HDPE plastic. Yeah, this is probably the most slow television you will ever watch, but the cool thing about it is that 10mm end mill removes so much material. I think I have some videos of it. Come on, load. It's not loading. You can always put a 4th axis on your machine later on. Just need another controller. Need a controller that's capable of doing it, and yes, that's it. So, hang on. Just searching for the right video now. This is actually pretty cool. You can see that this is held down by a vacuum, so it's only mounted by 2 screws in the end, and it's a 2-sided milling operation, so it's hang on, where is it? Must be there. Yeah, it didn't leave much room in my control box for another drive. Also, my power supply will need to be upgraded. And yeah, trust me, I just installed 4 contactors outside of my controller box. I had to put another controller box on the first one to be able to have room for it. Really not finding what I'm searching for. Should be the one after that one then. Yeah, I think it's this one. Look at the amount of material being removed here. I think I removed the dust bin here, so you can actually see it. Look at the chip flow going from this. Looks like water. So this is 20mm of HDPE plastic, and I'm using this type of 10mm upcut end mill to cut plastic. You got the same dust shoe, awesome. You probably got the same dust machine as well. I have a green one, like a 2.5 or 3 kilowatts. Look at this. Look at the chip flow here. I love this. This is when you can see the machine is doing properly what it's supposed to do. Removing a lot of material super fast and super precisely. Look at that chip flow. Looks like a water stream. Imagining when I removed the dust from the dust cyclone, the dust removal tool, there was 3 full black plastic bags of HDPE plastic spoons. Looked like rice corns. I think you actually, if you join the CNC garage on Facebook, you can actually see Actually see all the dust, I guess. Just have a look on this. This is the CNC garage on Facebook. Look at this. This is all HDPE plastic dust. Oh, sorry. Where did the rest go? Yeah, there was supposed to be some other pictures, but... So remember to join Facebook, cncgarage.org. It's like that. facebook.com/cncgarage.org. Yeah. You should see the logo. We're live streaming on Facebook as well. So this is yeah, you can see this is going for hours and hours and hours. This live stream was for, looks like it was 5 hours or something. And then it had milled out, it was definitely not finished. And this was two-sided, so you can see it was engraved on the other side first, and then, yeah. Then this entire operation took like, I think it was 40 hours, yeah. Do you run your CNC machine full-time or just as a hobby? Well, it's just a hobby, but, you know, sometimes a hobby becomes more than a hobby. So tab width, tab distance, yeah. So I only want to have 1 or 2 tabs on each of these. Tab height 1 mm, 2 millimeters. 1 millimeter should be enough. You know, as long as you don't use the dust removal tool to suck out the debris between your component and the stock material, it kind of helps keep the component in place until you remove it with yourself. If you use the vacuum tool to suck away the dust during the process, the components came loose faster. So I'm just waiting for fusion now. You can see the amount of time it took to run these 5 operations went down from 1.5 hours and all the way down to 10, 13, 15, 16, 17. It's like from 1.5 hours down to half an hour. So you cut any metals? I always have to use tabs. Oh, really? Do you use tabs on metal? Really? Okay, that makes sense, I guess. What kind of machine do you have? I'm not sure. I'm not sure you're able to put some links in the chat, but you can tell me what the name of the machine is, and I'll Google it. So these are the new tool path, and there are some problems running this. Why is it? Let's have a look at this. So it's running 2 passes. It's running 12 millimeter depth over 2 passes is 6 millimeter per pass, and that's kind of more than a 4 millimeter bit can handle as far as getting a proper finish. Custom design built. Cool. Awesome. Do you have a page I can check out your business or hobby on? So I'm just waiting for the machine to think. Think before you walk. My vacuum table is probably strong enough to hold these parts in place as long as the parts are big enough. They have enough, they fill enough space on the table, then they get sucked down properly. But as soon as they become small as these ones, then it kind of gets troubly fast. Yeah, just a hobby which pays for itself at the moment, but no page yet. See if I can find some pics. Cool. Feel free to. What you should do is just make for now, just a Facebook page, or yeah, just buy a domain or something. I bought several domains, cncgarage.net, and that just forwards to my YouTube account.
I love
remember to click subscribe on my YouTube account. I really need those subscribers. I really need to reach 1,000 subscribers, so I'm able to get some advertising money on the videos I put up there. That's the only wish I have. 15,000 RPMs, 2.5. Yeah. Let's see how those tabs worked out. Where are those tabs? Rectangular tabs. Can't see them anywhere. Maybe there are none. So let's have a look at this. Multiple depth. Oh, maximum. No. We need 4mm at the most. Finishing step down should be at least 2mm, and we should go at least stock bottom -1. Yeah, that makes sense. Top height, sure. Yeah. Looks good. Even step downs is okay. This looks pretty alright. So we should use ramp so we don't plunge down into the material. I don't like that, but we could increase the angle so we don't take, so the spiral doesn't take an hour. Yeah, this is kind of a hobby that actually does pay for itself. You're not able to kind of run full time with these kinds of tools, but you are able to definitely pay down whatever you spend on it if you're a little bit smart. But the most important thing is when you do something like this, it's have fun. That's why we're doing any hobby. As soon as it's not fun anymore, then it's not a hobby, and then it kind of collapses on itself. And yeah, just make sure you're having fun while you're doing anything you want to do in life. So I really think I should restart Fusion because it's not supposed to react like this. I've never seen this before. Yeah, I'll just do a quick reboot. I'll just save it. I'll just close it and open it up again. And now it's uploading the... Fusion is cloud-based. Ras, where are you from, by the way? Are you from US or Europe or anywhere else? And what type of CAD CAM software do you use? You use Fusion like I do, or SolidWorks, or AutoCAD, or... So UK, awesome. We're in the UK, London or somewhere else. I'm located in Norway, down in a town called Fredrikstad in Norway. Down south of Oslo. But I do have a brother living in London, so so let's see if we can... I'm just loading up the project again now. See if it runs better now than it did a couple of minutes ago. I work in CAD CAM, so got access to most. Awesome. Mainly SolidWorks, yeah. I did some SolidWorks. My Autodesk is getting much better than my SolidWorks skills at the moment. So, while we're waiting, when I do live streams, I run something called OBS, and I found a plugin for OBS that actually uses the NDI protocol. NDI is a new tech network video protocol, and I installed a cool app earlier today that makes me able to use my iPhone as a camera. I haven't tried it on the stream yet because I just installed it, but we can try it right now. So this should be my mobile camera in a second. Well, that worked perfectly. It didn't work at all, actually. So why isn't it? I'm just gonna fool around with this for one more second while Fusion is loading. No, it didn't work. That's how it is with everything the first time you try it, I guess. So the output is new tech NDI, yeah. Resolution should go down. Frame rate should go down. The bitrate is okay, I guess. And let's try it one more time. Oh, there it is. Well, there it was. So this is live from my iPhone. The frame rate is horrible, I guess. Yeah, I'll just skip that. Still not quite there with the network video, I guess, but if it actually says so in the application itself that it's recommended to use a USB cable to get the proper bandwidth because it's demanding so much over Wi-Fi. So let's just have another look at this once. I wonder what's going on with this. It's never that slow. That was weird. So you work in CAD CAM, so you kind of work with designing. Do you work as a technical design drawing type of work, or do you do CNC operating as well? Where is my tabs? I can't see my tabs. Let's turn off the stock material. See if we can see some tabs. Oh, if we decrease the distance between the tabs to maybe like 10 centimeters, that's like 100. So I have been running this stream for 2.5 hours now, and I can feel my throat is kind of clogging up a little bit. So I think I need like a 2 minutes of not talking. So I'll just shut up for a couple of minutes while I do some work. Design mainly, but as we manufacture in-house, there are so many cool tools. CNC mills, ladders, laser casting, lasers, casting facilities. You probably mean laser cutters. And then you have casting facilities. Yeah. Awesome. Remember to click follow, and I'll follow you back. You know, I just do this for hobby, but of course the dream is to work with this stuff, I guess. I was actually considering on buying a laser cutter a little while ago, but the cheap China-based CO2 laser cutters for like 100 watts or something, they kind of just work for the laser tubes. The CO2 leaks out of the glass container tubes on those laser cutters, and they kind of stop working after a while when the CO2 is magically gone. And then the cost of getting a new CO2 laser tube to Norway is incredibly high. It's like the tube itself costs 100 watt laser tube costs like 5,000 kroner or 500 pounds, and then it costs like another 500 pounds to ship it to Norway because it's fragile and blah blah blah. And then when it arrives, it only works for half a year, and then it gets broken again. Tabs. Where are my tabs? My tabs are missing. But I really don't think I need tabs on this. Yeah, you need to have water so your throat doesn't get too tired. Yeah, definitely. I had 2 cups of coffee, but that didn't help at all. Yeah, I'll just go grab some water while Fusion is clogging up. I don't know why I've never seen this before. Fusion usually works pretty good, but it gets even more expensive for VMC industrial CNCs. Paid 30,000 pounds for a new spindle. For a spindle, not a CNC machine. 30,000, that's like 300,000 Norwegian kroner, or maybe 400,000 or something, for just a spindle on the machine. Jesus freaking Christ. My cheap 3 kilowatts China spindle on the upper left there, I think that cost like 5,000 or 6,000 kroner or something. But I guess I follow a lot of CNC groups, and Tormac has a lot of good machines. They have just released some new ones, and they're expensive, but they're not helicopter rich expensive. It's like 150,000 kroner, maybe 15,000 pounds or something. For you probably know what Tormac is if you do some CNC. Yeah, my 2.2 kilowatt was 150 pounds. All right. Yeah, we got it easy. Yeah, definitely. In Norway, we have MVA limit, the customs limit when you buy stuff. Everything about 35 pounds is then you have to pay customs, and that's 25% extra MVA months. But one of the big problems now they're talking about is they're removing the MVA limit on everything you buy from abroad. So next year I will have to pay MVA for every small little, like this one 10mm end mill. This costs like, I don't know, $15 or something, and I have to pay 25% extra on all of those small purchases. That sucks a lot. But well, The government decides. So I should really save this. Yeah, you have the Brexit, so you have you're not able to acquire anything without paying huge amounts of money, I guess. They have the same in Sweden actually. So when the MBA limit has been removed from yeah, there's no lower limit anymore in Sweden, so the all of the buying from China and all those places kind of collapsed, and then people are buying locally again. And the positive thing about that is you take care of the jobs, you keep the business in the country, and that's important, definitely important. Can never say that too many times, but unfortunately for the man in the middle, the guy that does this for a hobby needs to get his tools cheap. I think I fucked up my fusion. I really think I need a reboot or something. Something is definitely going on here. It's not using any resources either. It's just, I think that it's just a bug. Absolutely nothing. Crap. And I can't do a restart without reconnecting to the stream either. So I guess I will be down for a couple of minutes while I reboot. If you don't have any other good suggestions. Trump wants to increase it even further for the states. Yeah, I know. You can already see that you know, the steel import from China has gone up. So, for example, Tormac that makes CNC machines in the States just upped their pricing a lot, because they make all their, well, a lot of their CNC stuff in China, and then they import it, and then they rebrand it and do quality control and blah blah blah. But you can see though they just increased their prices with like, I don't know, 5 or 10% or something. And I guess that's all Trump. So yeah, I just need to reboot, guys. I'm terribly sorry about that, but I'm not able to work without having a fusion that works. So I'll be back in approximately 3 minutes. I have an M2 drive, so it should go fast. But sorry. Yeah, I'll be right back.